So here is section 4.4. These three rules of logarithms, you got to make sure you know. If you have a multiplication inside a logarithm, you can split them up by addition. If you have a division, you can split them up with subtraction. And if you have a power to a power, we can drop that power down in front. Okay, so let's use some of those powers to complete problems 1, 2, and 3. So it says use the product property of logarithms to write the logarithm as a sum, then simplify if possible. So in the first one here, we have a log base 10. So keep that in mind. Now I'm not going to write that 10, but keep in mind it is a 10. And so because technically these three things are all multiplied, using our product property, we can write that as the log of 2 plus the log of x plus the log of y. And so if we could simplify, we could only simplify if one of these things sitting right here was related to the 10 we don't see, that little magical 10. So that one's done. Now let's look at number 2. Now this time, please note that we have a log base 2, and we still have a multiplication, so we can split it up. So this is the log base 2 of 2 plus the log base 2 of x plus the log base 2 of y. Now the only way we can simplify it is if something inside here is related to the number 2. That's what this one is. Because of that, what power do you put on a 2 to keep it a 2? Well, that would be a 1. So when they say simplify, that's what they're talking about. We can do a little simplification. No, not much, but a little bit. Okay, let's do number 3. Now, be very, very careful with this. Think about what we are supposed to do. This is the multiplication. We do not know how to split up an addition. We do not know how to split up an addition. So this is basically the natural log of 3 plus the natural log of a plus b. Okay, and you can't go further, you're kind of stuck. Okay, any questions on 1, 2, or 3? Okay, let's keep going. Now, it says for 4, 5, and 6, we are going to use our quotient property because we have a fraction. Now remember, it is going to be the log of the top minus the logarithm of the bottom. Now, it starts out as a log base 7. We have to write a log base 7 every single time. Okay. Now, in this particular one, this one needs to simplify. So what power do I put on a 7 to get the number 49? And that would be 2. So that gets replaced with a 2. Yes, we had a question. Oh, there you go. Thank you. We didn't have a question. We had the answer. I appreciate it. Thank you. Let's take a look at number 5. So number 5, it would be the log of the top minus the log of the bottom. Now this one was a trick. Here's where the trick comes into play. 14 is 7 times 2. So we could rewrite this. Let me get it so you can see that a little bit. As the log of 7 plus the log of 2. Now, the reason I wrote it in parentheses is because this becomes that sum. And so this minus out in front has to distribute to both pieces because both the 7 and the 2, which made the 14, are in the bottom. So this is the log base 7 of A minus the log base 7. I forgot my little 7s there. Of 7 minus the log base 7 of 2. Now, the only piece that is related to the number 7 is that one. That's the only piece that's going to change. And so our final answer would be the log base 7 of A minus 1 minus the log base 7 of 2. So that is number 5. Now for number 6, there is a log base 10 there. We do not have to write it unless it helps you. If it helps your brain, write it. And so this would be the log of 100 minus the log of x plus y. We cannot break up an addition or subtraction, only a multiplication like we did over here. So that is stuck. This we can evaluate. The log of 100 is 2, because what power do you put on a 10 to get 100? That would be 2. And then we are kind of done. We can't go any further. Does anyone have any questions about 4, 5, or 6? Okay, so this next property is kind of an interesting one. We haven't used the power property yet. What that allows us to do if we have a power is to drop the power down in front. So this is really 5 times the natural log of x. This is 5 times the natural log of e. Now, the natural log of x we can't do a darn thing about. But the natural log of e is what power do you put on an e to keep it in e? And that would be 5 times 1 or 5. So that's kind of a neat thing that happened there. Let's talk about number 9. A cube root is a 1/3 power. So the rule is this. Let me kind of write it like this. That might help you. A fractional exponent can be written as a radical, and a radical can be written as a fractional exponent. So in this particular case, we want to write this as a fraction. The top of our fraction is the power inside. The denominator of our fraction is the index that's hiding in the radical. If you don't see it, remember it's a 2. And so number 9, we could write that as a 2/3 power. So remember, this is the power, this is the index. Now, what we can do is use our power rule and drop that 2/3 out in front. Sometimes that's going to be really essential and helpful, sometimes not. It just kind of depends on where we take it further once we have some logarithmic equations we have to solve. Any questions on 7, 8, or 9? Okay, let's keep going, So it says to write the expression as a sum and difference of logs. So now they kind of all mixed up, and we're going to use all the different powers. We're going to use the product, the quotient, and the power rule. Okay. So the first thing, when I see a fraction, you're going to split it apart. So it's the log of the top minus the log of the bottom. And so since it started out to be a log base 3, keep using that log base 3 throughout the problem. This piece still has a multiplication, so we can split it up. So it becomes the log base 3 of 5 plus the log base 3 of z minus the log base 3 of w. Okay. Now you can do a shortcut in a way. All of the pieces on top can be added. All of the factors on the bottom can be subtracted. So this could be the log base 7 of A plus the log base 7 of C. See how the top things are added. but you're going to subtract the log base 7 of 5 minus the log base 7 of d. So if we have a fraction that has multiple powers in it, or I'm sorry, multiple factors in it, you will notice that these two are both positive. They came from the top. These two are both negative. They came from the bottom. And each one of those got their own unique logarithm. Now that can only happen if the things are multiplied or divided. An addition or subtraction we can't split apart, just a multiplication. So I'll give you a second to look at 10 and 11. Any questions about 10 and 11 before I move on to 12? Okay, let's look at number 12. Now, this is a multiplication, so each one of those things are going to be positive. There's no division here. So we're going to do the natural log of the first thing plus the natural log of the second. Now, the rule is if either of those things have a power, we can take this power and set it down in front. So let's take the 2 off and set it out in front. Since they're very different, one's a natural log of x, one's a natural log of y, there's nothing we can do about it. That's as far as we can go as far as expanding it. So like if Alex ever asked you to expand a logarithm or write a logarithm as sums or differences, that's what they're looking for. Any question about 12? Let's move on to 13. So the first thing I would do is I would rewrite the top as an exponent instead of that radical. So remember, this is the top of our fraction. This is the bottom of our fraction. So that's going to be a 2/3 power. Now, another thing I like to do is if I have two pieces, I like to put them in parentheses to remind me that they're stuck together. You know, that they're one and the same. They're stuck together. So remember, it is the natural log of the top minus the natural log of the bottom. We can't do anything about that because we can't split up an addition or subtraction. But here, we can drop that 2/3 down in front for a final answer of 2/3 natural log of x minus the natural log of w plus z. How was 13? Any questions there? Okay. I'm sorry. Sometimes, you know, when I've been teaching all day long, I start to talk too fast. So if I ever do, you just let me know and I'll slow down a little bit. Okay. Let's look at 14. So for 14, the first thing I notice is that the whole entire fraction is trapped. When the whole fraction is trapped inside of a radical, let's rewrite that as a 1/2 power. Because what we can do is we can use the rule immediately to drop that power down in front. So let's take this power and get rid of it by dropping it down in front. Now, that 1/2 is going to multiply by every single answer that we get, every single piece, because next I'm going to split apart this fraction. Every factor on top and every factor on bottom are going to get their own unique logarithms. Remember, the top factors are going to be positives or additions. The bottom are going to be subtractions. So we're going to get, I'm going to put the 1/2 just there for now. I'll put a 1/2, I'll distribute it eventually. So we get the top factors, the log base 2 of 4 plus the log base 2 of x. So those are the two factors on the top, the 4 and the x. Now let's focus on the two factors in the bottom. So we're going to subtract off the log base 2 of y. We're going to subtract off the log base 2 of z cubed. Okay? Now, let's focus for a minute on what we see. The only one related to the number 2 is 4. So, tell me, what power do I put on a 2 to change it into the number 4? 2. So this is going to become a 2. The only other thing I see is this 3 here is going to have to distribute, or not distribute, I'm sorry, drop down in front. Because it's a power, it's allowed to do that. Now the only thing left I think I'm going to do is let's finally take that 1/2 and just multiply. It's going to set in the front, or it's going to set in the front of each logarithm. And so our final answer, 1/2 times 2 is 1. That's 1/2 log base 2 of x minus 1/2 log base 2 of y minus 3/2 log base 2 of z. And so that is our final answer. Not real lovely, but it kind of is what it is. We can't really break it down further. We can't make it any nicer. Any questions about that one? Okay, I'm going to squish this down just a little bit so that. Okay, so now let's look at problem 15. I am going to break down, luckily we don't have any square roots, yay, but what we do have is 3 factors on top, 1, 2, 3. We have 3 factors on the bottom. So let's break those all apart. Remember, all of the top factors are going to be positive. All of the bottom factors are going to be negative. So this is the log base 8 of 64 plus the log base 8 of x squared plus the log base 8 of y. Now that's all from the top. Okay, so that's just the 64, the x squared, and the y. Okay, now let's deal with all the factors in the bottom. We're going to subtract each one of those. So it's going to be minus the log base 8 of 3, minus the log base 8 of z, minus the log base 8 of w cubed. Now the only thing we can do next is if any number is related to the number 8, we can deal with that. And we can drop down the powers. Any questions about how I got to that step before I do the next step? Okay, next step. This is a thing that can reduce. You're going to ask yourself what power to put on an 8 to get 64. So that becomes a 2. This thing can drop the 2 down in front. Doesn't do much good, but that's how we expand something as far as we can. The log base 8 of y, no changes. The log base 8 of 3, I don't know what it is. The log base 8 of z, I don't know. The last thing we can do is drop that 3 down in front. There are no terms that are alike that we could smush together. There's no like terms. They're all different. We can only add a log base 8 of y with another log base 8 of y. There's nothing that matches. It's disgusting. It is what it is. We're done. Any questions about number 15? Okay, now, so take a look at 15. We had that singular logarithm that we split apart into 6 long pieces. What the next section is going to do is take and do the opposite. So let's think about the steps we took. Let's look at this step. We simplified and dropped the powers down. So that's going to be our first step, to unsimplify and put the powers back on. Then all the pluses became multiplication, and all the minuses were division, essentially. So we're going to reverse that process now for 16 and 17. So our goal is to rewrite it with one logarithm. Let's not leave any coefficient out in front. That needs to pull back in as a power. Okay, so let's start with 16. The first thing you want to notice is there are no coefficients. They're ones. If the coefficients were something sitting there, we would pull that in as a power. So we don't have to worry about that for number 16. All we have to worry about is the fact that there is a subtraction. So everything that is positive is a multiplication. It would be in the top of our fraction. Everything that is minus is going to be a division. Now, this is one thing. It's stuck together. You cannot pull it apart. And so the log of 4x minus 3 goes on top. X goes in the bottom. Bam, you're done. We can't do anything else. Okay? Everybody understand or have any questions about 16? Let's take a look at 17. Please note that this 4 has to be the first thing we change. This 4 has to come in and become a power before we can try to bring anything together. So this is going to be the log base 2 of z plus the log base 2 of y to the 4th. Once we have coefficients of 1, like you don't see a coefficient there, now it's time to bring them together. All the pieces that are positive can come together as a multiplication. These are both positive, so we're going to multiply. And so this is the log base 2 of z times y to the 4th. If you could physically multiply them, you'd multiply them. You can't. You kind of just leave them next to each other. In any order, it doesn't really matter. Any questions about 17? Let's move on to 18. So for 18, first thing I notice is this 3. That is the only coefficient out in front, so the 3's got to come in. That's our first step. So this would be the natural log of x cubed plus the natural log of x minus 2 minus the natural log of 5. So our now we're going to look at the signs. Everything that is positive is going to go into the top of our fraction and multiply. Everything that is negative is going to go in the bottom of our fraction. And so this is going to be the natural log of x cubed times x minus 2 over 5. So you'll notice all of the positive pieces are in the top. All of our negative pieces are in the bottom. Any question about 18? Now I noticed 19 is a little bit icky, but it's okay. We'll figure it out. We'll do it step by step. Okay. I notice in my innermost parenthesis there are 2 separated logarithms. So let's go ahead and rewrite that. So I am going to ignore the other junk for a minute and try to get that together. So inside the parenthesis, minus means to divide. So this would be the natural log of x over x squared. Okay, that's going to be the natural log of, let's just call it 1 over x, I guess. Okay. Okay. Next thing we want to do is bring in the front coefficients as powers. So if we square that, that's the natural log of 1 over x squared. Because if you square a fraction, just square the top, square the bottom. This back piece, we're going to bring this 2/3 and multiply by 9. So just do 2 times 9, get 18. 18 divided by 3 is 6. So this is going to be the natural log of z to the 6th minus the natural log of z. Now, everything that is positive is going to multiply. Everything that's minus is going to divide. So that's going to be, look at what's happening to our z's. So our z is going to become z to the 5th. So that's going to be a z to the 5th on top. And our x squared is going to pop to the bottom because it's the only fractional piece after this cancels out. So we have now taken what was once lots of pieces and pulled it together into one fraction. So let's take a look at number 20. So the first thing I notice is we have to take that -2 and bring it inside. So this is the log base 5 of x plus 5 to the -2. Now, all of the pieces that are positive, which is everything, is going to multiply on top. Now, let's talk about some things here. So they're all just a big string of multiplication, but this has a negative exponent on it, which means division. So let's do some fixing here. So that would put an x plus 5 squared in the denominator. Then we've got our x. Now, the only thing I want to do is I want to break this apart because there's an x plus 5 hiding in there. That's going to be x plus 5 and x minus 5. So one of these is going to cancel, just one. And so, yes, this is a complicated one, isn't it? And so if one of these cancel, we're going to be left on top with an x and an x minus 5. And on the bottom, we're going to have an x plus 5. I will say they're usually not quite that complicated, but any questions I can answer about 20? Okay. So we're almost done. We're getting there. So, because you have to rely on a calculator or your knowledge of bases and things, for 21, 22, and 23, they have told us what the log base b is. We don't know what b is, so we can't really enter it into a calculator. It's not a log base 10 or a natural log. But they've given us some information which is going to allow us to solve for what these things are. Okay, so look what they've told us. They have told us what the log base b of 2, 3, and 7 is. Well, what does that mean? All of these numbers must be related to 2, 3, and 7. So let's think about the log base b of 21. Well, 21 is 7 times 3. So because we know some rules about the product, we can split that apart. That is the same as the log base b of 7 plus the log base b of 3. So we know what those things are individually, so we can add them together. So this is going to be 1.2091 plus 0.6826. You just add them up, and I'll tell you what it is. 1.2091 plus 0.6826 is 1.8917. Okay, that's just for practicing kind of an application, a numerical application of some of those rules. Let's take a look at 22. Now you can think of 9, because we only need to relate it to the number 2, the number 3, or the number 7. You can think of this as 3 squared, or you can think of it as 3 times 3, whichever will work. If we think of it as 3 squared, we're going to use our power rule and drop that down in front. So that's going to be 2 times the log base b of 3. Well, we know what the log base b of 3 is. It's 0.6826. So this is 2 times 0.6826. And 2 times 0.6826 is 1.3652. Before I move on to 23, does anybody have any questions about 21 or 22? Let's look at 23. Now this is a fraction. So remember, it is the log of the top minus the log of the bottom. What's great is we know what the log base b of 7 is and the log base b of 2 is. So we can just subtract them. So this is going to be 1.2091 minus 0.4307, just the values they gave us. So if we subtract them, we get 0.7784. Anybody have any concerns or questions about 21, 22, or 23? Okay, so finally, we are going to learn the change of base formula. Now, if you start out with a log base b of x, and they are not related, so b might be the number 2 and x might be 27. Those two are not related numbers. If that's the case, you can do the change of base formula. You will notice that these two match. Here is my inside number. Here is my little base. I've heard some people say the log of the tall over the log of the small. Let's see if that helps you kind of remember it. I tend because that base can be any A base, I tend to use this version of the formula, the natural log of the tall over the natural log of the small, natural log of x over natural log of b. It just allows you to use a calculator to calculate any logarithm that you want. But you got to be careful because it doesn't always give you an exact answer. Okay, it gives you a decimal approximation to so many decimal places. So, last two problems for today. Number 24, the log base 7 of 15. If we wanted to approximate that with a calculator, 7 and 15 aren't related, so we can't use what we've learned about logarithms necessarily, so we can use the change of base formula. So this is the natural log of the tall divided by the natural log of the small. Natural log of 15 divided by the natural log of 7. What's great is now we can use our calculator. And the natural log of 15 divided by the natural log of 7 is, to 4 decimal places, 1.3917. Now let's do 25, last one. So it's the natural log of the tall divided by the natural log of the small. So the natural log of 0.3 divided by the natural log of 5. Well, the natural log of 0.3 divided by the natural log of 5, you should expect that it's probably going to be a negative number. And the answer is, to the nearest 4 decimals, negative 0.7481. So just use your rules of rounding and round it to 4 decimal places. And like if you're doing these for Alex, just watch what Alex is looking for as far as how many decimal places to go out. And most calculators are going to have your natural log button. So that's why I always tend to kind of use your natural log. Okay, so that's our last problem. Are there any questions before we say goodbye? So I will post these finished notes as well as the videos either today or tomorrow. Unfortunately, like I said before, Wednesday we're going to have to meet virtually. So we will be meeting at 5 o'clock for everybody on Wednesday.